Hello everyone. In this segment, we found out how Runge Kutta second order method is used to find out the solution of a simple ordinary differential equation. In this tutorial, we take an example of Heinz method example. The formula of the Runge Kutta second order method is yi uh, plus 1 is equals to yi plus half k1 plus half k2 h. H is step size. The value of k1 in the first iteration when I is 0, k1 is equal to function of xi comma yi, and the k2 is equal to function of xi plus h and yi plus k1h. In the second iteration, the formula will become y2 is equal to y1 plus half k1 plus half k2 into h, and k1 will become function of x1 and y1, and k2 will become function of x1 plus h and y1 plus k1h. So we take an example that how Runge Kutta works. Somebody gives an equation in the form of dy by dx and equals to 3e power minus x minus 0.4y, and gives an initial condition that y sub 0 is equal to 5, and 0 is x naught and y naught is 5, and tell us that and ask us that find out the value of y at x is equal to 3, and they also give us a step size of 1.5. It means it uh, it takes two steps to find out the value of 3. Our initial condition is 0, where we lie. We take one step out to find out the value of 1.5, and when we second step out, we are able to find out the value of 3. Solution. Formula same, yi plus 1 equal to yi plus half k1 plus half k2 into h. In the first iteration, we will able to find out the value of 1.5. So y naught equals to half k1 plus half k2 into h. Okay, the value of function k1 is equal to function of x, value of function at x naught and y naught, and we put these two values in the function 3e power minus 0.4 into 5. It will turn out to be 1. Value of k1 is 1, and for value of k2, and then function value of function at x naught plus h comma y naught plus k1h. The x naught is 0 and step size is 1.5, y naught is 5 plus k1 will turn out to be 1 and step size 1.5. So this is the value of approximate value of y at x is equal to 1.5. This is not exact, this is also an approximate value. So we will find out the value of function at these two values. So k2 will turn out to be minus 1.9306. We put these two values k1 and k2 in the equation, where y naught is 5 plus half k1 is 1 plus half k2 is minus 1.306 and two step size of 1.5. This whole turn out to be 4.302. This is approximate value of y at 1.5. At x is equal to 1.5. This is not exact, this is approximate value. Please keep in your mind, this is a approximate value. So for second iteration, we will able to find the value of y at x equal to 3. So in this case, we have x1 is 1.5 and y1 is 4.302. So the equation will be y2 is y1 plus half k1 plus half k2 and into h. The k1 will be same, will be find out by same method, f of x1 comma y1, and x1 is 1.5 and y1 is 4.302, and put these two values in the function, and the answer turn out to be minus 1.0519. And for k2, f of the function of at x1 plus h and comma y1 plus k1h. X1 is 1.5, step size is also 1.5, y1 we found out that 4.302 plus k1 is minus 1.0519 and step size of 1.5. and this whole turn out to be 3.0 comma 2.729. So the value of K2 will become 0.939406. We put all these two values K1 and K2 in the equation, and Y1 is 4.302 plus half K1 is will become K we will find out that minus 1.0519 plus half K2 into H. The whole answer turn out to be Y2 is equals to 2.808. This is approximate value at 3.0. This is not the actual value or true value. This is approximate value at x is equal to 3.0. So if we find the exact value at y at x3, it's 2.763, and when you find out the absolute error, it will become 1.63%. This is a very less error as compared to other methods. So we end we will take an end of this segment. Okay, thank you very much.